back all the way like the gentleman just did a couple minutes ago, I can type the word do and then show run, and it will work. So I can see that I now have VLan 10, VLan 20, they're there. I do not have any IP addresses. So, are we ready to add IP addresses to these interfaces, these VLAN interfaces? Anybody not ready to go on? You're not ready to go on? How to add the interface? Interface space VLAN space number.
There's a bar under there.
No joy? You got it? All right. So then do the same thing for VLAN 20. You do the description while you're in interface configuration mode. All right, so go back into interface VLAN 10, and the IP address for that one's going to be 192.168.10.1 with a subnet mask at 255.255.255.0. So how we do that is the command IP space address space IP number and that one. And then immediately after the IP address, you put the subnet mask. In this case is 255.255.0. When you're all done, you hit enter. From here, I can do show run again, and see that my VLAN 10 now has an IP address. My VLAN 10 now has an IP address. Okay. You can do the same thing for VLAN 20. You can do the same thing for VLANs 11 and 20 on R1. Okay. So, actually on R1, I'm going to go ahead and do this. I'm going to add the 192.168.11.1 and the data VLAN on R2. So, on R2, big T, interface, VLAN 11, description, data VLAN, IP address, 192.168.11.1, right memory. Now, I need to create an Ethernet link between Fast Ethernet 00 on R1 and Fast Ethernet 00 on R2 with the following information. That IP address on R1, that IP address on R2. So, if I come to R1, and I change my interface to Fast Ethernet 00, to add an IP address, same command, IP address, or I can just use IP add for short, 172.16.1, yeah, 1.1, 7 mask 255.255.0, And then on R2, I do the same thing, interface F00, IP add 172.16.1.2 this time. Mask. Now, if I do show run and look at R2, a little bit of common sense here. Who can tell me what's wrong with fast Ethernet 00? Anybody? Read what's under interface fast Ethernet 00. Who can tell me what's wrong?
No show.
Yeah, it's shut down. It's off. It's off. Interfaces are left off by default. On layer 3 interfaces, layer 2 interfaces are left on by default on Cisco equipment. Okay, layer 2 being a switch, which the 1/011, those are layer 2 ports, and the fast Ethernet 00 is a routed port or routing port. It's shut off by default. So I have to turn it on. And how I turn it on is I basically take that shutdown command out of the equation by preempting it with the command no to turn it on. So if I go into interface fast Ethernet 00 and I type in the no shut command, which is short for no shutdown, I will turn it on. I'll turn on the line protocol. It'll change the physical state to up and the protocol state to up, but it'll fail because it doesn't see the other side. It's CR1, so you'll get another message here that it went down momentarily. Okay? If I switch over to R1 and do the same thing, I still have to do no shut on its fast Ethernet 00. And you'll see it come up. Okay? So, I can Control Z back. And if I want to look at the performance of an interface, if I want to look at you know, is the interface up? Is it working? Is it, you know, how much bandwidth does it have? How much throughput has it going on? I can use the show interface command, or SHOW interface, and then the interface number. So for, in this case, fast Ethernet 0/0. And I can pull up the statistics for that interface. What that does is it tells me that fast Ethernet 00 is up. The line protocol is up. Line protocol for fast Ethernet is Ethernet. So what this is effectively telling me is layer 1 is working. Layer 1 is working. Okay? The protocol being Ethernet. Okay? Carrier signal is there. That's what this first up means. It sees some form of carrier on that physical media. Okay? Tells me a little bit about the MAC address. This is the hardware address, which we'll learn here in the coming chapters what that actually is. This is a physical address of that port on that router that cannot be changed. Your IP address is your internet address, your logical address at layer 3, which can be changed. The big difference between a layer 2 address and a layer 3 address is layer 2 is constant, never changes. Layer 3 is changing. Okay? Your maximum transmission unit in bytes, your bandwidth in kilobits per second, your delay in uniform seconds, the reliability of the link, the transmission load, the receive load, the encapsulation, the duplexing, what other, your input queue, your 5-minute input and output rate in bits per second. So this is the actual throughput, not the bandwidth, throughput of that link. Okay? Your bandwidth is here. 100,000 kilobits per second, or 100 megabits per second, if you convert it. And this is your actual throughput. You can change these parameters from 5 minutes all the way down to 10 seconds, okay, with other commands that you can do on the link, on the interface. Okay, and it gives you other types of information, the total packets that have been output, input, interface resets, etc. So now, I'm going to test this link. The way that I test this link is with the ping command. Okay, so I'm on R1, my IP address is 172.16.1.1. I'm going to ping R2, which is 172.16.1.2. Hopefully, if I did everything right, it brings up the link, it transmits those packets, which are ICMP packets, we'll talk about it at a later time, and it should give me some series of exclamation points, or what we call in the industry as bangs. Bangs are goods, dots are bads. Bang is good, dot is bad. Remember that. Now, if I do that a few times and just kind of generate some traffic, and I go back and I look at my interface again, I can do the show NF00 for short instead of typing out that one long show interface fast Ethernet 00 command. Again, network engineers are what? Lazy. Inherently so. Alright? And I look at these statistics again, you can see that I have more packets output, more bytes. Okay, I haven't hit my any type of input rate limit at all. But you can see that I do have packets going in, packets going out. So, next thing I want to do is set up RIP on each router. So, not hard. What RIP is it is a very basic, rudimentary routing protocol. It's how you can set up a network in a, quote, dynamic, unquote, fashion without having to do a lot of coding to tell the router what networks are on, what networks do I need to get to, where are they, how do I get there. Not a lot of what we call static routing. It learns everything dynamically. So, RIP being a very, very basic routing protocol is what we call a classful protocol. Meaning it only looks at classful boundaries. Okay, we'll get into that when we talk about IP addresses. Okay? So, I go into configuration mode and I type in router RIP. I have to tell it what version I want. There are 2 versions of RIP. Alright, the latest one is version 2. Always try to use version 2 where you can. And then I tell it what networks I want it to advertise. So, there are 3 networks that are going to be attached to both routers. The 10 network, 172.16 network, and the 192.168 network. Okay? So, type in net 10.0.0.0, net 172.16.0.0, and net 192.168.0.0. I go to R2, I repeat that process. Router, RIP. Version 2. Net 10.0.0.0. Net 172.16.0.0. Net network 192.168.0.0. Okay. Now, unfortunately, RIP is kind of a slow protocol. Show, router, RIP.
You want to see? Stop. Do it again.
Show IP. Show IP RIP. So it's detected the 172.16 and 172.16.1 networks. That's good. If I do a show IP route, it still sees them as connected. Okay. Now the bad thing about GNS3 is I cannot connect up anything along the lines of VLANs. These VLANs, if I did a show interface VLAN, I think it was 11, it's going to be up, but the protocol's down because I don't have anything physically connected to any port on that VLAN. Therefore, it sees itself as down. If I were to actually plug something into the VLAN, like a computer, a phone, some other type of device, it would work. So, we can try that by going into one of the switch ports, hit F, say 1/0. Typing in the command switch port, mode access. This is not part of lab 1, I'm just kind of giving you an additional kind of primer here. Switch port, access, VLAN 11. Let's see here. Okay. Older versions of iOS, you have to add the VLANs to what is known as the VLAN database separately. This is not part of your lab. You don't have to do this. But if you ever come across this in the field, how you do that is you type in VLAN database. The prompt changes to VLAN configuration mode. And then you add the VLANs manually in that fashion. VLAN 11, name, data. Okay, VLAN 22, 22, name. Go back, I'm going to do that. In newer switches, in newer switch modules, you don't have to do that. Unfortunately, it's kind of a legacy thing that has to be done. All right, now, my VLAN is still down because I have nothing attached to it. So, hit F 0. I'm going to do this on 1. And switch port, mode, access, switch port, access, VLAN 10. And I can even do switch port, access, switch port, voice, VLAN 20. So what I've done basically to this port at this point in time, I've done a couple of additional commands. Again, this is not part of your lab. You don't have to do this. This is just good additional information. I've set up this switch port with 2 different VLANs. One access VLAN 10 for data, one for a voice VLAN. This is unique to Cisco switches because you can put a voice VLAN on here. It's still considered an access port, but in essence, it's known as what we call a trunk port because we have 2 VLANs operating on one switch port. A very common type of deployment in Cisco voice architecture. Very, very common. Very, very, very common. This is like step 1 in getting the network prep to roll out IP phones. All right. So now I can go back to GNS3. I only have a couple more minutes here. If I look at end devices, I'm just going to grab something, anything, I don't care. I'm going to put it on that port that I just put up. And I'm going to do one over here. And this one. I don't care, just grab any that I can, put it on F10. Let me quickly go back to R2 and finish up what I was doing before. Still not able to get it up and running here. Yeah. Yeah. Up, down. That brought it up. And all I did was bounce the line. Go back to R1, do the same thing. Shut, no shut. It's now up. So scroll down though? That kind of sucks. I'll play around with that a little bit. Anyway, what should have happened is those VLANs should have come up and I should have been able to see the RIP environment.
They have to sign the IPT4 gateway.
Sorry?
IPT4 gateway.
Nope. That's the beautiful thing of a routing protocol. All that information is transmitted across it, across the link. Okay. So, yes?
How do you delete the VLan?
How do you delete the VLAN? No space VLAN. What are the VLAN numbers? Okay. So, for the purposes of the lab, one minor change here. So I'm not going to be able to see that VLAN 22 or VLAN 10 from R2. They're not coming up. So instead, what I want you to do for here is grab a screenshot of your interface, your VLAN interface. Your two VLAN interfaces on R1, your two VLAN interfaces on R2 instead of doing that ping test. All right? So if I do a show int VLAN 10, and I see that it's up, that's all I'm looking for. Screenshot, show int VLAN 20. You need to get that one up like I did the other one by basically all I did was take a host, drag a host down, and connected it to R1. The switch port configuration you'll have to do. The switch port configuration you're going to have to do as well. And how I'm going to get around that is I'm going to save this. When I save it, I should have those configs saved as well in my folder. If I browse to that, /users. My username, GNS3, projects, Brown Lab 1. Whatever you name the project. Configs. Uh-oh. That's no good. Something went awry. Write them. R1. Write them on R2. Try that save again. Much better. Don't forget to do your right mem. All right? Don't forget to do your right mem. Yeah, much better. All right, so here's what I'm going to do. I'm going to post the progress of this onto Blackboard so that you can grab these files, you can see the configs, you can work them from there. You can load these into GNS3, you can retype the commands, however you want to do that, that is fine. You need to finish up the switch ports on each end, the VLANs on each end. Take a screenshot of the show interface VLANs. The show interface VLAN numbers, 2 of them on each side. Do that instead of the pings. They need to show up. Okay? You need to connect up a host for each VLAN. So when you connect up your host, you need to connect it to your fast Ethernet port that you assigned it to the appropriate VLAN. So you should have 2 hosts, like I have here, one on VLAN 10, another one on VLAN 20, and on R2, one on VLAN 11, another one on VLAN 22. That's how you will get those VLANs up. Okay?
Show me again. You're connecting your phone.
Sure. Pull the host down. Okay. I then right click, add a link. Get my cursor. Okay. I have all kinds of different links that I can choose from. Doesn't matter at this point in time. You can choose your local area network connection, your wireless link, any loopback addresses you have. I have several VMware, that's why I have so many here. But if you only have like 1 or 2, you can just pick one. It doesn't matter. It's just going to look at the physical layer signaling. That's all it's going to look at. We're not trying to pass packets back and forth. We're not trying to do anything to that level. All right?